Autonomous systems have rapidly transitioned to physical and financial actuation, independently initiating irreversible, real-world actions on a massive scale. Modern agents currently possess the capacity to trigger bank transfers, migrate production databases, and command physical infrastructure without human intervention. Every maneuver made by an autonomous vehicle is the immediate translation of digital intent into physical reality, occurring in real time. The moment a system crosses the threshold from making a recommendation to executing an action, the outcome becomes permanent. For an enterprise, this shift creates a new category of risk. This stack represents the current enterprise safety architecture. Organizations rely on three paradigms to secure this flow: model alignment, identity and access management, and observability. Model alignment, or Layer 1 safety, applies guardrails to the model itself. It governs what an AI is allowed to say, but it cannot control what an autonomous agent actually does once a decision is made. Further down, identity and access management checks the permissions of the account, but it ignores the intent behind the agent's specific action. Meanwhile, observability simply records the event, often logging a disaster after the data is already gone. This structural void creates the execution gap. Without a control layer at the point of action, unreviewed agent executions create direct, unmitigated financial and operational exposure. TrigGuard functions as a deterministic authorization kernel, a brainstem that bridges the gap between AI reasoning and real-world execution surfaces. Consider an AI agent operating inside a major financial institution. Based on market data, the agent decides to autonomously execute a $10 million trade. At this scale, a single error carries immediate consequences. A wrongful execution creates legal and regulatory exposure that can exceed hundreds of millions of dollars in fines and market losses. To prevent a catastrophic error, the institution cannot rely on the AI's internal logic. The system must intercept the request and evaluate the action through an independent, deterministic gate before it reaches the market. TrigGuard catches the AI's probabilistic request, translating it into a strict canonical intent. Surface inference identifies the target API endpoint. The authorization engine then evaluates this intent against hard-coded enterprise policies. Finally, risk analysis verifies the agent's identity and acceptable financial parameters. By removing the AI's probabilistic reasoning from the chain, TrigGuard reduces a high-risk request into a purely mathematical logic test. The architecture is fail-closed. If a policy doesn't explicitly permit an action, the system defaults to blocking or suspending it for human review. In our trading scenario, policy checks pass, generating a cryptographic receipt. This receipt acts as offline verifiable proof, containing exact policy references for why the action was approved. The final pre-execution gate demands this signature, only opening to let the $10 million trade hit the execution surface. This is a critical structural distinction. The AI requested the trade, and TrigGuard authorized it. Every approved and denied request leaves behind a permanent, immutable audit trail. Organizations now possess hardware-verifiable proof of every autonomous action taken by their systems. Producing this deterministic proof is becoming a legal requirement. Under the EU AI Act and DORA, enterprises must provide an exact accounting of AI-driven decisions. A pre-execution audit trail contains the blast radius of a malfunctioning model, protecting organizations from cascading multi-agent errors and the penalties of a regulatory breach. Deterministic execution governance is now mandatory compliance infrastructure, driven by the convergence of widespread agent adoption and new regulatory pressure. Just as Stripe established the infrastructure for global e-commerce and Okta secured human identities across the cloud, TrigGuard is building the foundational layer for AI execution. It provides the definitive authorization infrastructure required to manage a global machine workforce. Securing this layer is the prerequisite for scale. It allows organizations to deploy agents across high-stakes environments, from defense logistics to healthcare and critical infrastructure. Artificial intelligence can finally be trusted to act with true autonomy, because enterprises finally have the deterministic infrastructure required to authorize it.